Welcome back. This is section 7.2, Newton's third law. In your textbook, this is 6.2. So Newton's third law specifically states that an object will exert a force, if an object exerts a force on a second object, that second object will exert an equal and opposite force on the first. So opposites are equal, or forces are equal and opposite, or forces always occur in pairs. So if you've got two forces, one that's acting on the first and then that one giving a force back, we need a name for each of these forces since they're opposite of each other and then they're in opposite directions and equal in magnitude. So the first one is called an action force. So if I put my foot against the ground and push against the ground, what's making me go forward is the ground pushing back on my shoe. So I propel myself forward by pushing back on the ground and the ground shoves me forward. That's how a car goes. If a car had no friction at all, it would spin its tires and not go forward. But since it does have friction, it's going to push back on the ground and the ground's going to push forward on the tire, and then the car, as it grabs, will go forward. So you're going to get an action force, me pushing on the ground, and then the reaction force of the ground pushing back on me. So they're always going to be paired. You're going to have a set of paired forces, an action force and a reaction force. They're equal in magnitude. So if I push 3 newtons, the ground pushes on me 3 newtons, etc. And they're opposite in direction. So if I push to the left, it pushes to the right. So if you're going to state this, to every action there is always an equal opposing action, or an equal and opposite reaction. And so I guess it doesn't matter which direction you want to think of it. If one is the action, the other is the reaction. If I hit the wall, I would probably think of that as the action, and the wall breaking my hand would think of that as the reaction. So in every reaction, the forces always occur in pairs. So here's some examples. You push against the floor pushes against you, the tires impact the road pushes on the tires. When you're swimming, you push on the water, and the water pushes on your hand and makes you go forward. So that's how you swim. The interactions in these examples depend on friction. So the force that's actually making me go forward, it depends upon the friction force. If there was 0 friction, I could not walk across the floor. Even walking across ice, I can walk across ice or a mopped floor that's wet because it's not 0 friction. It's very slick, but it's not perfectly slick. If I couldn't get any traction at all, nothing I could do to make myself go forward by walking. I have to have some friction to do that. So without action, there can't be a reaction. So for instance, if you have say a box on the table, it's exerting a downward force of weight. The support force goes up. It's not in dynamic motion. It's just static. It's staying there. And so there's no motion. Motion would depend on an action, reaction force with friction in many cases. So what happens if she tries to get to shore? She's going to end up getting wet. She pushes back on the boat, but the boat can't push back on her because the boat is free to move on the water. There's no friction holding the boat in place. And since she can't, as she pushes on the boat and the boat moves, she can't propel forward, and so she can't get to the dock and she gets wet. So what happens when an object exerts a force on another object? That second object exerts a force back on the first object, equal in magnitude and opposite in direction.